Hey everybody, welcome to this edition of the Microchip Technology live stream. As always, we're coming to you live from our corporate headquarters here in Chandler, Arizona. This is your opportunity to interact with us, to ask a question on today's topic, which is smart design using clickboards in Atmel START. I'm Mark McComb, and joining me in the studio today is my good friend Partha Sarthi Shenmugam. And before we get going with everything, what I'll do is I'll send you over to Matt Dickens and Wayne Freeman to give you kind of an overview of how to interact with us.
Hey Mark, thanks so much. Yeah, my name is Matt Dickens. For those of you watching for the first time, those of you back, welcome. This is my co-host, Wayne Freeman.
How are you doing there?
I'm doing well. I'm
Wonderful.
Excited and ready to go. So yeah, couple quick things, just logistically wise. First thing is, if you want to ask questions, there's two great ways to do that. I'll be following the chat through this whole live stream. So if you guys have any questions, feel free to post that up in the chat, and we will get those questions to our hosts, Mark and Partha. As well as if you are looking to win a fun prize, we will have a couple prizes handed out at the end, and we'll be picking those from the people that are interacting with us. And lastly, if you also want to ask questions but you don't want to throw them up in the chat, feel free to email us at livestream@microchip.com.
All right.
Does that cover it?
That covers it. It looks like we have a couple of people in the chat right now. It looks like Armstrong's there. How are you doing, Armstrong? Hopefully you guys are having good weather down there.
Yeah.
I guess we'll throw it back to Mark and Partha.
Yeah, take it away, Mark.
Thanks, guys. So just to kind of give you an overview of what we're going to talk about today, the whole goal with all of these live streams are to help you, the customer, get up and running rather quickly. So we're going to talk about some easy-to-use hardware. We're going to talk about some easy-to-use software. And to that point, we have Partha here, who is one of our experts on the START ecosystem, which we'll be talking about today. Welcome, Partha.
Thanks, Mark. Thanks for the kind introduction.
Oh, my pleasure. Can you just give our viewers an overview of what you do here at Microchip?
Yeah, I am part of MCU8 applications team.
Okay.
Mainly, we involved in developing the drivers, middlewares, and example application for the START ecosystem.
Okay. So anytime a customer goes in and interfaces with START, uses the drop-down menus, any of the content you're showing today, that's your team that's involved with that?
That's what we do.
Okay. So viewers, this is your chance. If you have any questions about START, anything that happens under the hood, here's your chance. Partha's here. So what we're going to do is we're going to demonstrate these easy-to-use tools using a demo. The demo we're using here today, Partha built, that uses a number of clickboards, and we'll talk about the clickboards as we go through this. It's also using a number of Microchip explained boards for various AVR devices and the CAN bus system. So Partha, can you just kind of give us an overview of what's going on here?
Yeah, sure, I can do that. So this is a smart sensor node control system, actually what I have built here. So it built based on the clickboard support.
Okay.
So we have all the clicks here.
Okay.
And each node has two different types of clicks, sensor click as well as the communication click.
Okay, so if you look at each one of these individual nodes, they have these CAN communication boards.
Yes,
okay.
yes. So each node has a CAN communication board connected to the CAN bus.
Okay.
And it has its own sensors here. So for example, this is Tiny817, which has the touch sensor here.
Okay. And there's the touch sensor.
Yes, this is the touch sensor.
All right.
And this one is Mega 328FB. It has a CO sensor actually, a carbon monoxide sensor.
All right.
And this one is the weather sensor. It's XMega128A1.
Okay.
So all these sensors are connected via CAN bus. And this is the centralized node which has the connectivity to the PC.
Okay, so any information that's going up to the
Yes,
PC is going
yes.
through this board here.
Yes. So this can be easily replaced with Wi-Fi or Bluetooth just by changing the communication part of it.
All right, so for users or viewers who are not familiar with the MikroElektronika clicks, they communicate over some very easy, very common communication interfaces. So these guys, for example, they communicate over SPI?
Yes,
correct?
SPI.
So if you wanted to swap out these CAN modules for something like a Bluetooth Low Energy or Wi-Fi or some other communication you can do that. We're using CAN here today, but it doesn't mean you're limited to
Yes.
CAN.
So this adapter has all the ports available, like I2C, I2C, SPI, UART. So all the pins are available. So you'll be able to just plug and play.
And these, again, are very common peripherals that you'd find on almost any of the microcontrollers in our product portfolio.
Yes.
Okay. And so why don't
I can even show you the dashboard actually.
Yes,
so as
please.
of now,
Yes.
it's running currently. So can we have the screen, please? Okay. So here is what the dashboard I have.
Okay.
So it shows all the parameters, real-time data.
So from each one of the nodes.
Yes.
That's pretty cool. And so let's try this out here.
Yeah,
So,
you wouldn't you touch this
Yeah,
temperature
so-
or humidity
so if we
sensor.
go back to the camera, I'll just show. So this first node here has the CAN bus node, but it has a weather click on there.
Yep.
And this weather click has a humidity sensor. I'm going to go ahead and press that, and you'll see the light over here come on,
Yes,
correct?
yes. So
Okay.
what it really does, it sends the data over CAN,
Okay.
and this node receives it and processes it, and if it goes above the threshold, it turns on this light.
Cool.
So, kind of control system as well.
Okay. If we go back to the dashboard or to Partha's computer, we can actually see this working. It's the
Yeah, this
So
is
right
the
there.
humidity part.
Yeah.
As you can see, the value changes.
so how did you
turns
build
on.
this dashboard, this GUI here?
Yeah, this dashboard is built using Node-RED,
Node-RED.
open source tool called Node-RED,
Okay.
and it's easy drag and drop tool, and you will be able to configure the COM port. So basically, what it does is it sends the data to UART,
Okay.
serial communication. So from the serial communication, it sends in JSON format. I just drag and drop the JSON parsing, and
And JSON being
Redirected
part of
to
the
the-
JavaScript.
yes,
Okay.
yes. So I am using the JSON format for the transmission.
And this is open source, free
Yes,
to use.
this is free, and then you don't have to do much coding here.
Okay.
So you just drag and drop stuff, and then it works out of the box.
So you don't have to go in and do a big.
Yep.
Okay. very
Yeah.
cool.
So it has different controls: output, bar, graph, and pie chart. So we are just using it. So that's what you're getting here.
Excellent.
So why don't you try this touch? Like it's kind of volume. And
Oh, sure. Let's go back to the dashboard and just show the touch controller.
yeah.
So that one, look, you're moving the volume.
Yep.
Okay.
It's so smooth.
That's pretty cool. All right. So Partha, so we're using these clickboards here. And I mean, let's kind of break this demo down piece by piece. So the first thing let's talk about are these clickboards. So can you give us a bit of an overview of these? What kind of clickboards are available?
Yeah.
Where would a customer get these clickboards?
Yeah, these clickboards are MikroElektronika products actually,
Okay.
and this clickboard contains microchip devices basically. So these are available from MikroElektronika website. You will be able to get those clickboards, and these clickboards vary from sensor nodes, communication interfaces, and then HMI touch interfaces. So you see most of them here.
And as you mentioned, this CAN communication system is made possible using these microchip expansion or these expansion modules.
Correct.
Okay, so that brings up a very good point. If your microcontroller or your application doesn't have a particular capability on it, so again, CAN bus we're using here, or something like a wireless communication module or something like that, or even something to do with Ethernet, a wired communication module. Microchip sells this whole line of extension modules that you can connect to give that functionality to your application.
Yes.
And they're designed to work with our microcontroller, so even better, right?
Sure. So we do have some devices which has inbuilt CIP actually. K83 devices has inbuilt CAN module.
Oh, okay.
So
So we do have devices
So we
that
don't
have it, but
need external. So, but whereas most of the cases we need some external interfaces. So it makes.
okay. So I think we may have a comment from the booth.
Hey, yeah, Mark, we just wanted to give a quick shout out. There's a lot of active participation on the chat, and I wanted to honor that. So, hey, everybody there. I think I see a Praveen. Hey, Praveen, how are you doing? We have Reek. We have Akash. Vignesh, thank you for answering Akash's question. And I think that brings up an awesome point that we'll definitely be trying to answer your guys' questions, but feel free to stay active in the chat. That helps us out, and obviously that helps you guys out as well, because the more questions we can get answered from users, the deeper questions we can answer live here. So thank you guys so much for staying active. And Mark, why don't you talk to us a little bit more about what's going on with the clicks?
Okay. So now we have this whole ecosystem of clickboards, and don't worry, we're going to show you the MikroElektronika website a little later in the show here. But right now, let's talk about. So you've got these clickboards connected to these baseboards. Can you talk a little bit about what's going on there?
Yeah. So these are different AVR devices I try to use here. So for example, this is a tiny 817.
Okay.
So it's a tiny family of devices.
That's a fairly new device.
Yes.
Yeah.
And this is Mega 328PB.
Okay.
This is a Mega family. And this one is X Mega 128A1.
All
so
right.
we have all AVR families here.
You have the whole.
Yes, I covered all the AVR families
Very
here.
cool.
So these devices vary based on the pin count, pin peripheral power usage, and memory.
Okay.
So based on your application need, we have all this variant, and then you'll be able to choose one.
And just a note on these new tiny devices, the 817s, they came out, I think, almost about a year ago, maybe?
Yes.
And they have some new capabilities on there called core-independent peripherals that you may have seen up in the X Mega families, but we moved some of these capabilities down into the tinies, and they just provide a really nice complement to these applications. If you want to maybe offload the CPU and put the task into a peripheral, you can do that. There's a powerful peripheral called the event system.
Yes. We even do have the configurator for the event system.
Right.
So the START has the infrastructure.
And that's a good point. Like when we go into START, you'll see how easy it is to configure these peripherals. You may not fully understand what a peripheral is. If you don't, you can read like a little introduction in the data sheet on it, and then go and kind of explore it inside of START.
You can directly go and configure it. You don't have to start with datasheet. You will have START for that.
Yeah,
so that's our main intention. You don't have to go back to
well,
that.
but I mean, you know, if you wanted to get like a description of what the peripheral is intended to do, yeah,
sure.
I think the datasheet would serve a good purpose there.
Yes.
So we're connecting into these explained boards, and you have a couple of different varieties. You have the Mini, and you have the Pro. Can you explain kind of the difference between those two?
Yeah. So the mini boards are kind of equal to the Arduino compatible board. So we have Arduino Shield compatible. See, as you can see here, this adapter is Arduino adapter.
So where did you get that?
Yeah, from MikroElektronika.
MikroElektronika sells it.
So you can use the same adapter for the Arduino as well as for these mini boards.
Okay, and what about the Pros? How do you connect
Pros
them?
are standard connectivity, which uses the micro bus. So we have provided this micro bus interface.
Okay.
The extension boards can be connected via this.
So just to point out here that if you look at the boards, the Pro boards, you'll see they have these extension headers on them. And what the goal with those is to connect into these Xplained Pro extension boards. And we sell a bunch of those for, there's some for I/O, there's some for LCD, and so on, analog interface, and so on. And the board Parth is talking about here is this microbus extension board, which actually allows you to connect in here and then connect the MikroElektronika Click
board. Yeah.
Cool.
So here there are 3 extensions are possible here in this board.
Okay.
The X Mega being the high performance device.
Right.
So we support multiple peripherals.
Wonderful. Okay. So that kind of gives you an overview of the whole demo. Now so we looked at the hardware. I mean, if you want to get up and running with the demo hardware-wise, it's pretty easy. They make all of these little clickboards. They make these interface boards, and you can see Parth has connected these using just a simple 2-wire twisted pair interface.
Yeah, the CAN specification.
Over the CAN specification. And so part 1, right? You want to get your application up and running. You don't have to do a lot of breadboarding. Chances are there might be a circuit board that MikroElektronika has put together for you, or a Microchip extension board for the Pros. That takes us to the next part, and the part that you truly are an expert in, and that is the START ecosystem. So can we kind of take a look at what this project looks like inside of START?
Yeah, I can show you that.
And then while we're opening this, I think we have a question in the booth.
Hey, yeah, Mark, thanks so much. We got a couple great questions from the audience. The first one being, do the clicks use Microchip drivers?
Yes, that's a good question. The click uses Microchip drivers. For example, this CAN click 2515.
Okay.
So MCP 2515 is the CAN click used here. Okay. So we have a driver for that. So we have the click middleware which has the driver inbuilt with that middleware.
Okay.
Yep.
Wonderful.
Cool.
Hope that answers.
Yeah.
Thank you, Partha.
Sure. Thank you.
A second question, and this is a great one. Is the CAN click production ready?
CAN click, yes. I think MikroElektronika has got the CAN click. This MCP 2515 is kind of old device, so
right.
we should have the enough pieces, I guess.
So I think part of the question, and maybe I'm wrong, but this is how I interpreted it. But Microchip, one of the nice things about using these expansion modules, and we'll take like a wireless communication module as an example, is that it takes it's a module that's been certified. So I mean that takes it off of the customer, so they don't have to go out and go through this lengthy certification process. So we actually provide these modules not only to make it easier to interface with, but also to make that part of the development time a little quicker.
Sure.
Okay? Hopefully that answers that question.
I think that even depends on the MikroElektronika stock warehouse also, right?
Right.
So the production level, but the device is out there.
Yes.
So it's Microchip device, we have the device.
And we'll show you when we go to the MikroElektronika website from within START that if you wanted to take this to the next step, you prototyped it, or you've demoed it, now you want to take it to an actual physical prototype, then you can, the schematics are available on that website, and they're all open. You can see them and build this yourself if you want.
Yes, talking about the schematic, we can even see how can we get these details about the click.
Absolutely. So let's go into START and take a look at Partha's screen, guys, and then we'll just see how this looks on the software end of things. So first thing we're doing here is we're on the START homepage.
Yeah. So if you are on the START homepage, there are two different workflows we have.
Okay.
Creating a new project and browsing an example. So when you go to examples, these are the built-in applications, ready-to-use applications specific for certain types of boards. So here I can even categorize based on the technology here. It's a Bluetooth. If you're interested in Bluetooth, I can select the Bluetooth and download this example and try directly on the board.
Okay.
It works out of the box. This is one workflow.
And if you wanted to see that example, what it looks like in START with all the way everything's connected, that's possible
Yes.
as well? Okay.
Yes. It opens up the complete example.
Oh, nice.
With pre-configured.
Okay.
So you don't have to change anything. If you just download and program it, it works.
Okay.
So that's how it is. That's the example workflow. And new project workflow, if you go to new project, we have filters, everything here. So you try to provide your requirements here. So what exactly the peripherals you need, what exactly the hardware requirement you need, what exactly the software requirement needs, it provides the device. It filters out the device.
So if you know the click you want to use, can you find that on here?
Yeah. Here, if you just scroll down here, clicks are part of middleware.
Okay.
By the way. And there are different types of technology here, mixed signal, clicks, and we have different category here, like storage clicks, sensor clicks. So I'll try to open accelerometer click.
Okay.
So when I select this accelerometer click, what it really does is accelerometer uses I2C. So it filters out device which has I2C.
So again, you can search for parts based on your requirements, and instead of going in cold and trying to figure out what you need.
Yes.
That's awesome.
You can do that as well, and even the drivers also. You can provide number of modules you need.
So if you wanted to
ADC you need.
If you wanted to have an ADC, or if you wanted to have a PWM.
Yes.
Okay.
Let's say you need multiple ADC module, then you just select multiple ADC, select two ADC. It filters out only the device which has two ADCs. So that really helps you.
Nice.
To select the device.
Okay.
So we have a complete portfolio of all the devices, all the AVR families here. Mega, Tiny, X Mega, as I said. So we will be able to choose the device.
So we know we have the 817 Xplained PRO, right?
Yeah.
So how would we locate that?
Yeah, you just You can, if you know the device, you can just directly type here 817.
And all you typed in was 817 and
Yes.
found it. Okay.
So, and then you will be able to select the board as well. So for example, we have Xplained PRO here. I'll try to select Xplained PRO.
And what's the advantage of selecting the board over, say, just the part?
That's a very good point. Like this pin map gets populated if you select the board. So it knows the board configuration,
Okay.
and it loads the pin map for you.
Nice. So if there's an LED on the board or a push button, it'll identify
you
that.
can see that, and it configures the pin output configuration also. Like if it's an LED, it configures that output. If it's a switch, it configures as input.
Very cool.
It really helps you to get started.
It eliminates that, again, that aspect of running into the data sheet and trying to figure out all these port muxes and all that. Okay.
So I'll try to add a can click here.
And you just typed in the term can.
Yeah, maybe I'm very fast in that.
Oh no, that's good. It's good. That's how fast it is, right?
You can even search for it. Like the CAN module is part of the Click networking interface. Actually.
And one thing I like about this too is if you type in just the communication protocol, it'll even populate the clipboards, correct?
Yes, that's true. You just type for SPI, what are the clicks that's based on SPI, it gets filtered out.
Very cool.
So I have added CAN click here. I can configure the peripheral. So
now just going back to the CAN click, if I click on that main block, what am I presented with?
Yeah, if you click on the main block, the CAN configurations are presented. So
Okay.
you'll be able to configure the CAN parameters.
Okay, and so part of this is how you would, of course, the CAN parameters as you mentioned, but I believe there's also how the click actually connects into the AVR, correct? Which pins?
Yes.
And so I look at this board and I have I have the Xplained PRO, and then I got the extension header, and then I've got the clipboard. How do I know how to actually map those pins?
Yeah, that's a very good point you brought out. So recently we have enhanced our user document.
Okay.
So in that you'll be able to find out what exactly.
So hang on, guys. Can we go back to Partha's screen there?
Sorry.
And just if you can show them how to open that, Partha.
Yeah. So on the user guide, you select the CAN click.
You select the click.
Click and then go to the user guide.
Okay.
And you'll be able to see the details of that, like CAN SPI.
And so that's going to, so that shows you up top where you just highlighted is how you expect this click to work. Is that correct?
Yes.
Or, okay.
CAN SPI click.
All right.
The interface, we have a section called interface that provides you the details.
Okay.
Exactly. So all the user document has got an interface settings. If in case of UART, there will be settings for the baud rate and things like that.
Wonderful. And then above that is the actual pin connection.
Yes.
Really cool.
This is really helpful for the person who's getting started for the connectivity interfaces, like the MikroElektronika bus connections, things like that, specific to that board.
And this is new, correct? This
yes,
is brand new.
recently we released this.
So if you're familiar with the START ecosystem, and this has been kind of a gotcha in the past, anytime somebody says something, we listen, and this is an improvement that was made.
Yeah, this was a feedback, and then we really improved upon it. And as you can see here, for specific boards, we'll provide the interfaces available.
Okay.
So you just configure the specific connection for the board you have, and it works.
And you can get access to the micro site from here, correct?
Correct. So if you click on the image here, it goes to the MikroElektronika site.
Now, on the micro site, what would I find?
So on the micro site, you will be able to find the overview of the click, as well as in detail of this click also, like the spec, user document, or schematics, for example. So if you open up the user document, it opens the schematic for the click.
Nice.
So and this schematic contains the connective interfaces and the devices exactly what is being used here. For example, it's MCP2515.
And if you wanted to find the MCP, 2515, if you wanted to find the documentation for that, could you easily access that from here?
Yeah, from the MCP2515 documentation directly available here, you have to go here.
Okay.
Not
so
from the inside.
Nice.
So this goes to the Microchip
So, and if there's any app notes on this product, if there's any erratas, anything like that, you'll find on this page.
Yes,
so
this is our Microchip web page. So whatever the application node, the support we have, it will be available.
and then if you want to buy one, which we hope you do,
Yes.
you can just click the Buy It Now
Buy
button.
It Now.
Awesome. Okay, so if you looked at the advertisement for this live stream, you'll notice that we had a series of 5 questions that we were going to answer them, and we're gonna kind of pepper them through the presentation as we go. So some of the questions, and this is one of them that we're kind of trying to highlight here, is just how do I know the correct pins to connect to the clipboard? So hopefully that answers that question. I'll summarize these questions at the end of the presentation as well, so don't worry if you don't catch it right away. We're going to record it and make it available so you can go back and find those questions answered. Okay. So now going back to start, Partha, we have all that information on the screen. But if we go back to the environment there, guys, to Partha's computer.
Yeah. Sure.
So now that's that level, the click level. So now let's dive down to the next level here. So we're talking about the peripheral itself, right?
Yes. So here I can show you the project that we have done for this complete system. So that will be a good example to start with.
Okay.
So I have the project exported here. There are 4 different nodes are there.
Now, just for customers who've never used Start before, to get from Start to this point, now you have Atmel Studio 7 open here. So to get from Start to this point, depending on how you configured your project,
Okay.
how would you get that code into
Sure.
Start?
Yeah. Maybe I can show you for this node itself.
Sure.
Like it has a CAN. So I
Okay.
have a CAN module added here. And then it has the relay click. I'll try to add the relay. So relay is nothing but a GPIO. So I don't have to configure anything here for the relay, just the pin. And then I can go to export.
Now, you have a couple options there.
Yes. So we can export this project to Atmel Studio, IAR Workbench, and even the standalone Makefile.
So why would I want to export to IAR Workbench over?
Yeah, if some customer would prefer the IAR compiler,
Okay.
they have the license for IAR compiler, they can make use of it.
Wonderful. So I think we have a question from the booth.
So actually, folks, we don't actually have a question. We're unfortunately having a couple of technical issues with sync between the audio and the video. We're working on this, but I think that what we're going to have to end up doing to solve the problem is basically restart the stream. So what we're going to do is we're going to let Mark and Partha finish their demo, and we'll do a question and answer session on a separate stream after we're done with the main part of the program. So we're playing it by ear here to try and get some issues solved. So
Okay.
just so you guys know, back to you.
And again, after the live stream, if something is confusing because of all of this, you can always just email us. Matt will give you the email again at the end, and then we can answer those questions there. Or you can continue to comment on the video recording, and we'll definitely make sure that your questions get answered. Okay, so Partha, we talked about exporting. So now to physically, the whole purpose of Start is to actually use this graphical means to configure your product, to configure your interface, to configure your clipboard, and then generate software, correct?
Yes.
Okay, and so we're at this stage now. We've chosen the Atmel Studio. It looks like you can name your project.
Yes, I can name my project.
And now how do you generate the code?
So I just download it. So what it does, it downloads the AT-zip file.
Okay.
That's the format that Atmel Studio understands. And if I open it up, it opens automatically in Atmel Studio and imports it, create a project for you.
Wonderful. Okay, so now we're at the point where we've generated our code. We're in Atmel Studio. Why don't you walk us through some of the modules that?
Yeah. So I can switch to this project here. So this application, I can show you the real application here. So this application will have all the drivers in place, whatever the CAN and relay click basically. and then you will be able to add your own example here, like application code here, and there are examples available for you to get started. This is the starting point.
Now that's a good point with the examples. Can we go back to the Start ecosystem for a very quick moment?
Yeah.
There? And go back. So how would I generate an example?
Yeah, there is an option to enable the example generation here.
Okay.
So by default, we enable this option. Always the example gets
So
generated.
it always gets generated.
Yes, unless user don't want the example to be there.
Okay. Very
that's
cool.
an option.
Okay.
And you can even preview the code. So once you enable the example, you want to see the example quick view.
And that's before any code gets generated?
Yes.
All right.
So this kind of preview, you'll be able to see the code, what's getting generated.
Wonderful.
Yeah. So these codes are generated specific for this target. So there is a templating mechanism which generates for this specific target. So you don't see the if definition, like definitions, multiple definition for the multiple target. Like if the family of devices Tiny 817, you see code only for Tiny 817.
Right, and that just kind of minimizes bloat code. Right?
Yes.
Okay, so back to the modules. Sorry
back
to
to the
interrupt.
module here.
Yeah. Now, and just to let viewers know that there's a between Start and what you see here, there's a couple more steps. I mean, you're going to set up your project obviously the way you would any other Atmel Studio project. You'd have to, where's my project going to live on my PC? What am I going to name it? Is it going to be part of a solution? That kind of thing. But it's pretty straightforward. We've already done this in the interest of time. So
I think this. Can you switch to screen? Yeah, this is what the dialog you will get prompted when you import the project.
Okay.
So it will show you the path, everything in the file name, project name for Atmel Studio.
Okay. So if we go back to the open project and just go through some of those modules.
Yes. So we'll see this example here. For this example project, I have the can click and the relay click. So we'll be able to get started with the example code here. And in case if we want to change anything, the configuration, I can go to reconfigure options.
So this is just going back and forth between Studio and Start. So
yes.
I mean, it's not a one-shot deal. I mean, in the past, it was very much you configure it and then everything else is done in Start or in Studio. But now there's a mechanism to go back and forth and debug as you need to.
Yes, it's a development is an iterative process. Whenever you find something to be improved, you will be going back to that and change the settings. And what we have here, it's a seamless interface when you want to reconfigure. So you don't have to go back to the browser and do that.
Right.
You just right click and reconfigure. It opens up in the Atmel Studio environment itself.
And can you just highlight that button that you pressed inside of the Solution Explorer?
Yeah, okay, there are two ways to do that. Right click and reconfigure, and here there's shortcut button is here.
Okay, so if you click that button, it'll reopen
yes.
Start.
So for the current selected project, it opens it up.
Wonderful.
In the configuration view. And once you can, it's as good as in the browser, whatever the configuration you do, you can change the parameters and then hit generate project, it updates you.
Okay.
And there's one more good option here. In case you have changed the code, it will show you the difference as well.
So if you made some of your own edits in that software, any of that code that was generated for your own application, then it's going to identify, hey,
yes.
I'm about to overwrite that. So
yes, and you can see the diff as well.
And
what
now
we have added.
Now, if a customer, so that first window pops up automatically. But if you wanted to see this diff file here, you would have to download
configure, some compare tool. Like I am using WinMerge here. You can use any other compare.
And WinMerge is just an open source free differential file viewer. Okay, so now if you wanted to make some changes at runtime on your application, now as I understand it, Start creates some functions that you can use in the background. Correct?
Yes.
And so can you just talk about those for a little bit? And just if a customer wanted to make some parameter changes, so say something in the system happens and I need to change something in my setup, what do I do?
The callback mechanism. I think
Okay.
you were talking about the callback mechanism, yes?
Well, just any of the kind of the functions that have been created. So, for example, I'm running a PWM, and for whatever reason, I want to change the duty cycle. How do I do that? I come from the start environment. Obviously, while the microcontroller is running in the application, I can't go back to start. So I would need to call a function or something. Can you show us any of those?
Yeah, there are setter functions are there, setter and getter functions are there. If you happen to add that module specific to that module, you'll be able to do that actually. So these APIs are part of these drivers here. For example, I'm showing you the SPI here. So the init part, where the initial settings are done, and there are enable, disable. So these are all the hooks what you're talking about. So on the runtime, you will be able to enable, disable, change the values, things like that.
Wonderful. Very cool. Can we go back to start for a second?
Yep, I can do that for you.
Now, so one thing I wanted you to talk about here was if you go into the, now if some projects are going to utilize a UART, can you, the example will utilize the UART. Can you pull up some, like add a click or something that's going to make use of that?
Yeah, I can show you that.
Because this is a common...
this is a common question you get.
It's a common question, yes.
So I'll just clean few things here. I'll remove the CAN part to show you.
So now you pull open a clipboard and you look down under the submenu and you see this USART bubble that's dotted lined out. What does that mean?
Yeah, this is an optional driver.
Okay.
Basically, these boards, right, these Xplained PRO boards has inbuilt debugging capabilities. So we call it EDBG. So these provides a virtual COM port interface. So when you connect these boards, there will be a virtual COM port created for you, and you will be able to send serial data using that COM port.
And that's how you're kind of communicating with your dashboard in this
So in case if you want to debug or send the parameters, you will be able to do that. So this is, since it's optional for the debugging purpose, we made it this kind of option.
Okay. So now if I wanted to enable that, how would I do that?
Yeah, I just click that and it gets added.
Okay.
So one of the reason we made it this way also, some devices like Tiny8217, there are very less number of UARTs available. So in case if you happen to use for the click, you will not be able to use it for your application, real application purpose.
Okay.
So that's why we made it optional.
All right.
And once you added it, you will be able to see this option, printf support.
Okay.
So this gets enabled by default, and you just say printf the string, it comes to the terminal window.
Okay. Do we have a comment from the booth?
Hey, yeah, Mark. So we think we probably hopefully figured out the audio video issue now. So what we're going to go ahead and do for all you users out there is we're going to restart the feed on our end. And just to kind of what we're going to wrap up at the end is we'll take those 5 points that Mark mentioned and we will run through those 5 points at the end. And then we want to give you guys some more time for Q&A because we appreciate you guys sticking with us. And kind of as an added bonus, if you guys have stuck around to this point, is we're going to throw up a coupon code for you guys at the end. So anybody who's watching, we're going to shoot a coupon code for the, I believe it's the Explained Mini 328.
Yeah, it's the Explained Mini 328 PB. Very
so
good board.
If you guys stick with us for just a second, we're going to go ahead and restart that feed. We'll wrap it up, and then we'll throw that coupon code up for you guys. So stay tight for a second.
So thanks, Mark and Partha.
Okay.
Yeah.
Hi everybody, we're back. Hopefully the issues with audio and video sync are solved. So Mark and Partha, are you ready to continue your wonderful discussion that we're having here?
Absolutely.
Awesome. Back
Okay.
to you.
Thanks everybody for your patience.
Yeah.
So before the break, we were talking about the printf, the UART. One last thing that some users are getting confused about is if their example isn't running and it uses interrupts, there's a step that they need to take in order to enable interrupts, correct? So can we show that?
Yeah, I can show that actually. So there are two parts here, the peripheral interrupt as well as global interrupt. So by default, by configuring the peripherals, you are enabling the interrupt for the peripheral. Like for example, here we are seeing the interrupt mode, IRQ mode.
Okay.
So once you go to IRQ mode, all the interrupt related settings are enabled. Still, there is a global interrupt setting. So you have to enable the global interrupt to be able to get the peripheral interrupt. So we have a system module called CPU event.
Okay.
So you go to this module and then enable this global interrupt enable bit.
Okay. And all of those modules that are at the bottom of the upper part of the dashboard, those are all core centric modules, right?
Yes. So when you create just a plain project, these modules will be there. These are the system
Always
modules.
there.
So it's a must-have, the modules.
And those are going to be things like if you're going to enable sleep modes, if you're going to do brownout detect.
Yes.
Okay.
So one more observation here. There is an option here, toggle option to show system drivers or not. So if you disable that, you may not be able to see that model. So maybe that might be the reason customers might have missing this option enabling.
And that's all of this is part of the flexibility of it, right? I mean, it's when you have something that's flexible, you got to leave some of this stuff that the user has to do.
So what we have done here to avoid this situation, we have enhanced our user guide.
Okay.
So in our user guide, there's a column we have running the example.
Okay.
So as a part of this, we say enable this global interrupt from
Nice.
this. So you just follow this instruction given here, you will be able to run the example without any hassles.
Wonderful. Okay. So if we go back and kind of take a look at the main screen there for Start.
Yes.
One last thing I just wanted to cover. I mean, this isn't one of the 5 gotchas, but this is something that I think everybody should know. If I were to click on one of the peripherals,
okay,
and I go down into the configuration window, and say the second parameter or the first parameter in that window, I don't know what's going to happen when I check this box. How do I find out?
Correct. So you mouse over it, there is some description here given, and if you need more details, you just click on this question mark here, the small question here. It opens up the online data sheet for you.
Oh, very cool.
So it context specific.
Context specific. So it's not going to
So
start you off at page 1, it'll start you off at the page you
it
need
takes
to
you
see.
exactly what the register means. So
Okay.
you'll be able to get the detail out of the box.
Wonderful. Okay. So now we have a tool that actually generates code for us. Can you talk a little bit about this code? Some of our viewers may be curious as to, what does this mean to me? Like how much code does this save me to write? Is it efficient? Can we talk to that?
Yeah, actually, I can show you that this example, this project, the smart sensor node, right? This project, it's basically 4 different projects here.
Okay.
So I have configured, completely created using Start.
All right.
So all the drivers, clipboard, middlewares, everything is developed using Start. So the code I have added is only part of it. So can you guess how many number of lines this complete system, how many number of C lines?
Well, there's 4 boards, so I'll say 4,000 lines.
Okay, you're almost there actually.
Okay.
So I am using a tool here called count number of lines. It's an open source tool.
Okay.
So I have zipped my project and then provided the project to this tool. What it gives is the complete analytics of this project. So here the C code, number of C files, how many number of codes available in the C project.
Okay.
So in this complete project, there are 3,548 lines are available.
Okay.
So out of which So I have added 120 lines.
So out of all of this code, this 3,548 lines of code, you only wrote
120 lines of
120
application.
lines.
Yes.
Wow.
So it's like 4% of code only I have added for the application specific.
So the rest of this was generated.
These are tested quality codes that we provide to the customers to get started instance.
And that's a great point. So if I'm worried about this being, and that's always part of the development cycle. If you're building an application, there's a whole, I write code, I debug code. You'll find some mistakes. You'll go back and rewrite the code, debug the code. And that could take anywhere from days to months, you know, depending on the complexity of the application. This kind of takes some of that out of the equation.
Yes.
Okay,
it
cool.
really saves a lot of your time. That's called rapid prototyping. So
right.
We have 96% of code written it for you, and only you put the 4%.
You wrote 4% of
4% of application code.
That's awesome.
I can show you this example, like here, this weather click, right?
Okay.
So I have only 2 functions added here. See the weather click. If you see, 38 lines I have added as application code.
Okay.
So there are only 2 APIs: update weather, send can.
Excellent.
That's all. In update weather, I just read the weather, send it.
Wonderful.
That's all the code I have written. All underneath the weather parameters are coming from the APIs.
Excellent. So we have a comment or a question?
Hey, yeah. Thank you, Mark. So we have a bunch of great questions coming in, and I wanted to take some time just to answer those kind of over a few of the different things that we've talked about today. So a couple questions have just kind of been interfacing with START. So is START free? Can I use it offline? So can you kind of give us a high level of where and how START is available for users?
How we can obtain it.
Yeah, that's a good question. So here, START is an online system. You just go. You don't have to install anything. You just go to
the screen. Sorry.
Oh, okay.
Yeah, there we go.
So START is an online system. You don't have to install anything. You just type start.atmel.com. It opens it up for you, and it is free.
But it's an online tool.
It's an online tool. You don't have to install anything. And once you configured your project, download it, and you can download it as we showed you earlier. You will be able to download it for different systems like IAR, Atmel Studio, and even the standalone Makefile. So you'll be able to download specific for your application, for your environment, and then you will be able to start working on that.
Very
Again,
cool.
Atmel Studio is also free.
And Atmel Studio will live on your machine. And
Cool.
However, if you wanted to make edits, you would have to have connection to the internet. If you wanted to use START, you could make edits to the software.
Yes.
Okay. Cool.
There is no local version.
Speaking of software, now one question might be, how efficient is this code? So if I'm having a computer program writing the code for me, I mean, it's got to create a lot of code bloat, right? So
Yep.
what's our answer to that?
Yeah, this generates code whatever you configure.
Okay.
So for example, I have shown you this register initial setting part, right?
Right.
It enables the code whatever you configure. The remaining parts are commented out. It's almost as good as handwritten code.
Okay.
So it only provides the code you need.
And you know, one of the things I really like about this is that if you are unfamiliar with something on the microcontroller, and like we have a lot of new peripherals coming out, these core independent peripherals that kind of take the requirements of writing all this code for a peripheral. It may be confusing what this peripheral does, but you can go in, you can set it up and start, very high level overview, generate the code, and then if you need to optimize that code further or learn a little bit more about the peripheral, you can actually go in to these functions and take a look. There's nothing overly complex in there. And I mean, looking at some of this code, you were literally writing just hexadecimal files to registers. So translate that hex value into binary and you got your bit settings in a register.
The generated codes are not binary files, not the library files. It's all source. So you'll be able to go inside and then you'll be able to do the changes you need.
You have access to all that code. Nothing is hidden. Just like the schematics for the boards.
Correct.
Very cool.
Can we switch it to more? Yeah. Here, the comments, talking about the comments, in case if you want to change the file, right, you need to know what exactly or where to change.
Yes.
So we have a lot of comments here. Like for example here, out of 3,500 lines, for 3,500 lines, we have 3,000 lines of comments.
Okay.
So it's almost like 85% of command we have.
Right.
So
right.
that can really help you to understand
what's going on
actually.
Very cool.
And these are Doxygen, and you'll be able to generate the Doxygen API also, the standard Dox.
So
yes.
Doxygen, for those of us who haven't used it, is just a way to graphically show.
Yes, the API.
So how everything kind of communicates with itself.
Yes.
Oh, very cool. All right, and Doxygen again is free.
Yeah, we try to use.
Nice.
Yeah.
Okay. I mean, any of this stuff that we're showing here today, you should be able to reproduce at any of the software, no charge.
Cool.
Cool.
Yeah, thanks so much, Mark.
Okay.
We've got another question coming in, super high level. How many clicks are supported in START?
Yeah, there are 50 plus clicks are supported in START. So this activity started as a part of Click Start campaign.
Right.
So we had this Click Start campaign, right? So MikroElektronika supports hundreds of clickboards, and as part of this activity, we added 50 plus clicks.
Wonderful.
Cool. Awesome.
Cool.
And then I would be remiss if I did not tell you who the winners were for our drawing competition. So thank you guys once again, everybody that's out there. A lot of people ask questions. A lot of people are commenting, answering questions, asking questions.
Thank you so much. And by the way, I'd like to say hello to Adafruit Industries. Thank you for joining our live stream as well.
Absolutely. Absolutely. So the big drum roll for the winners, and the winners as well. So you're going to be receiving one of those Atmega, the Explained Mini 328 PB development boards for free. And the way that you're going to claim that is if you shoot us an email at microchip@livestream.com, send me your name, your number.
You almost got it right this time.
Livestream at Microchip. Dyslexia, man. All right. Microchip at Livestream. No, it's Livestream.
It's livestream at microchip.com.
There we
in
go.
In fact, hopefully we'll get Ricky to put it down in the comments. And we'll also try and put it at the bottom of the screen. Livestream at microchip.com.
Thank you, Wayne. I appreciate that. So we have two great winners, as always. And the first winner is going to be Vignesh Kumar. I am not going to try to pronounce your last name, but you won an Atmega 328 PB Explained Mini 328 PB development board. Jeez, words are hard. And our second winner is going to be Zinkal Bhat. So if you two can shoot me an email at, what was that, Wayne?
Livestream at microchip.com.
Thank you so much. And I think we have a time for a few more questions here. So taking us back to those for a second, I know we talked a little bit about how efficient the code was, and Partha, you showed us a few things about that. But can you talk to us a little bit about how is that code tested, or how do people know that they can trust it? What kind of a process do you guys go through to make sure that that's the highest quality possible?
Nice.
Yeah, this is a very important question, I feel. Okay, so when it comes to quality part, we have different types of testing mechanism here. The continuous integration test we have that runs daily, and we have some part of simulator testing as well. So all these codes are tested in the simulator as well as in the continuous build system regression, and we do have to do some manual testing as well. So
nice.
There are some manual testing before the release happens. We do some amount of manual testing because everything cannot be automated. But almost most of the steps, the driver part, we automate the testing.
Really cool.
It runs.
And
daily.
that's very important. I mean, that's kind of why we are doing these live streams, is to make sure you're aware, viewers, that we do offer these solutions to really try and help cut down your development time and still have a very quality, well-written application. So,
yeah, definitely. Thank you so much for that, Partha. And let's see what else. Oh, here's a good one. AVR extension only supports 3.3 volts. So how, if I use 5 volt clicks in my application, is 5 volt clicks supported in START?
isn't that a good question? We forgot to talk about that one, didn't
yes.
we? Yeah.
That's exactly right. So here in the Xplained PRO board, we have 5 volt as well as 3 volt.
Right.
So what you have to do, you can connect a jumper to 5 volt to the external interface. So it runs with 5 volt.
Because the board's running at 3 volts, or the chip on the board's running at 3
yes.
volts, so you had to actually physically, but there is facilities for a 5 volt.
There's a facility for that. So this board has the 3.3 as well as 5 volt. So you need to have a jumper over here and then connect it, and it provides 5 volt. And there are certain clicks, most of the clicks are 3.3, and there are some few clicks are 5 volt.
Okay.
And few clicks need 3.3 as well as 5.
Okay.
So you have to see the specification for that.
Very cool.
And we documented this as well.
Okay.
So whenever there is a 5 volt click, you have to do this jumper connection.
Okay.
So we have documented as part of user
Excellent.
guide.
Good. Great question.
Yeah, absolutely. And one last question I got. So I know we talked a lot about the CAN protocol, but can you talk to us a little bit about the other communication protocols that are available through the clicks or through START, or just kind of in general the different communication protocols that we support?
Yeah, you mentioned this briefly, and I think it was during the sync issues, but we also got a question about it on the stream here.
Okay.
Yeah, that's a good question here. On the wireless, can you switch to monitor?
Sure.
Yeah. So if I expand the wireless connectivity, click here, you'll be able to see different wireless options that we all support. BLE2, Bluetooth, and then GSM, that's again wireless. LoRa, RN4871, this is again Bluetooth and Wi-Fi. So these are all the different options that we have.
And those are
when
all
it comes to wireless.
And those are all modules that will interconnect with the 8-bit devices or any device that doesn't have
for
this,
that matter.
that has one of these common interfaces like SPI, I2C. Some of them communicate over, some of them communicate over USART.
Yes. So these are all the wireless related connectivity clicks that we offer.
Excellent. And the nice thing with a lot of these modules and these expansion modules that Microchip sells is that, like for example, like Ethernet or Wi-Fi, the stacks are actually on the modules. So if you have a low memory device, you don't need to actually have the facilities in place to store that stack. It's stored on the module.
Correct. Only your application goes
Yeah.
into the
Yeah.
device.
Cool. Thank you so much, Partha. So just to wrap us up for the live stream for the day, I wanted to make a couple announcements of things that are coming up. First of all, as always, please be subscribing both on YouTube and on Facebook.
Please.
That's where we put out a lot of our content. We're always coming up with new stuff. And just Microchip in general is putting out a lot of great stuff all the time. So make sure that you are doing both of those things. I also wanted to say that if you get super interested in this and you want to have more information, we do have masters conferences that we put on around the world throughout the course of the year.
Absolutely.
So if you enjoyed this live stream and are interested in hands-on training with our application and design engineers, you can attend one of Microchip's masters conferences. We have one coming up here in Phoenix in August and another in Berlin in September. And I'll go ahead and throw the link up for additional information in the comment section, the chat window for the YouTube.
And both of these cities are just fantastic places
Absolutely.
to be. So.
Absolutely. They're a fun time. We'll
And
be out there.
I think you know, I know Mark's going to be at the Masters in Phoenix. Partha,
yeah.
will you be attending any Masters this year? You
Not
don't.
sure. Last year I attended. This year,
You don't. You don't know yet, but I think we're going to get. I think we're going to get you out here. You're going to be very famous very soon.
okay. Hopefully.
Absolutely. Absolutely. You come out, get Mark's autograph. It'll be a good time. Yeah, I think that pretty much wraps us up. You can check out more great examples at microchip.com/examples to find some great stuff. I think Partha, you said you're going to go ahead and throw the example code up for us for your project as well, correct?
Yeah, as part of the example browser here,
And
we
that's
can
going to be
add
in
it.
Start. So we'll
That'll be in
we'll
Start.
put
Yes.
your screen up just one more time so you can kind of see where it's going to be. There you
Yeah,
go.
it's going to be in the browser example. So I'll add this sensor node application as a part of this.
Excellent.
Yep.
Cool. Well, I think that's all I have. Wayne, you got anything else to send us out?
Oh, I'm very thankful for all of you who stuck with us during our technical issues. We love the questions. We love talking with you. If you need to contact us in between streams, you can send an email to livestream@microchip.com. And you know, if you're a winner of the prize, the winner of the Explained mini board, please send us an email with your details. I think that's going to be a stream for the day.
Yeah, and we went ahead and threw that coupon code up for you guys.
Oh yeah, absolutely.
If you check that out, I think it's below my face on the live stream.
So
but
you can get you can get the same board for a very good price.
absolutely. The board we handed out, you can go ahead and grab one of those at, I believe it's 30% off.
At Microchip Direct.
At Microchip Direct. Yeah. So Mark, why don't you take us home?
Sure. Well, Partha,
Yeah,
I appreciate your time.
thank you.
Have a safe flight back to Chennai.
Sure.
everybody watching, thank you for your questions. Thank you for your time and your patience. We'll talk to you soon. Bye.